This video is a quick recap on how we can find the equation of a line. And if we remember, this is the format that we're going to write that equation in. So looking at our first example, y equals mx plus c. Now the m part, this is the gradient of the line. So how do I find the gradient of a line? Well, a number of ways you can do this. I just like to draw in a little triangle. Now, when you're drawing in your triangle, try and have it so that the line that you're finding the equation of, where it cuts the grid line, because it just makes it much easier to count some squares. So I've got it crossing the grid line here, and there's another point there where it crosses the grid line. So if I just draw in my triangle, now I appreciate it might be quite difficult to see because the lines are quite faint, but you'll have to trust me. If I look along here, this is 1, 2 along. So for every 2 along, I'm going 1, 2, 3, 4 up. Now the gradient of the line is the rise over the run. So this is the rise, how many up, divided by how many along. So in this example, the rise is 4, the run is 2, so my gradient is 2. Now I could have drawn a bigger triangle and I could have gone 3 along and then I'd have gone 6 up. 6 divided by 3 is still 2. There's nothing magic about the size of the triangle or where you draw it. Because it's a straight line, the gradient will be the same at any part on the line. So now we know what our m is. So y equals 2x. The plus c, this is the easier part. This is where it's crossing the y-axis. And in this case, it's crossing the y-axis at positive 1. Our next example, the gradient, let's have a look, crosses the crosses the grid lines here. So I'm going to draw this triangle in. Now, to find the gradient, I want rise over run. So the rise, I'm going up 1. The run, I'm going along 2. So for every 2, I go up 1. So the rise is 1 over the run of 2. So this gives me a gradient of a half or 0.5. So for every 1 along, I'm going a half up. So the gradient, if I put that into my equation, now you can write this as a half x. You could also write that as x over 2. Or if you wanted to, you could write that as 0.5 lots of x. They all mean the same thing. So I'll leave it as a half x. Now I need to work out where does it cross the y-axis. And in this case, it's at positive 3. One more example. This time you should notice that this is now a backward sloping line. So straight away, I should know that the m part is going to be negative, because I'm not going to go 1 along and then so many up. I'm going to go 1 along and so many down. So we're going to use the same method. I'm just going to draw in a triangle. I'll tell you what I'm going to do. I'm going to use those extremities. There we go. Draw a big old triangle in. So my gradient is going to be the rise. Now, because this is going downwards, I'm going to say it's a negative value. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to say a fall of 8 over a run of 2. And negative 8 divided by 2 gives me a gradient of negative 4. So the gradient is negative 4, so y equals negative 4x, and it crosses the y-axis at positive 8. Again, you might see this written like that, and that's exactly the same equation. All I've done is move that negative 4x to the other side of the 8.